Okay, buddies. So here we are. We're talking about how to solve molarity problems. In all of these problems, there's always going to be three numbers that you have to deal with. Two of the numbers are going to be in the problem, and then the third number is going to be on your periodic table. It's going to be the molar mass. And in each case, you have to use all three numbers. You have to use the two numbers in the problem, and you have to use the molar mass. Yeah?
Yeah.
So the first thing we're going to do always is we're going to start over here by writing the units that our answer is in. Sorry, it's not liters. It says, so this question says how many grams of potassium carbonate. So our answer is going to be grams of potassium carbonate. This one says how many liters of lithium bromide solution. So our answer is going to be how many liters of lithium bromide solution. Yeah, aqueous lithium bromide. This one says, what is the concentration? And concentration can be written all sorts of different ways, but we're talking about how to do molarity. So we know that our concentration is going to be molarity. And here we're talking about an aqueous solution of iron 2 chloride. So that's the first thing you're going to want to do is write down your units of your answer, because that's going to inform you of how to proceed. The second thing that you're always going to want to do is, this isn't the only way you can do it. I'm just saying this is a way that will always work. Start by writing those same units on the top of a fraction. So what units is this right here? So we're going to start with grams on the numerator of a fraction. And what's this one say? So we're going to start with liters in the numerator. And then this one's a little trickier. What's this one say? That one says molarity, but what's that mean, molarity? Moles per liter. That's right. So what do we want in the numerator if we're talking about moles per liter? We want moles in the numerator. We also want liters in the denominator, but we're going to do that in another step. Okay, let's just start with that mellow. Okay, now you always have to use three numbers. You're going to have to use this number, and you're going to have to use this number, and you're going to have to use the molar mass for the chemical. Yeah?
Yeah.
So here you're going to have to use this number, you're going to have to use this number, and the molar mass. Here you're going to have to use this number, and you're going to have to use this number, and you're going to have to use the molar mass. So always use all three. So which one of those three has to do with grams? Does 200 milliliters have to do with grams? No. 2.5 molar. 2.5 moles per liter. Does that directly have anything to do with grams? No. So it's not this number we're going to put here, and it's not this number. It's the molar mass of potassium carbonate. And potassium carbonate is 138.21 grams. So I'm going to put it up here, 138.21 grams per what?
Per 1 mole.
Per 1 mole. That's right, buddies. Per 1 mole. Nice. Okay. Now I got grams on top, and that's what I want. So I know that I'm setting myself up for success. I know that I do not want moles on the bottom, because look, moles is not on the bottom of my answer. So if I don't want moles, I need to get rid of moles. And how am I going to do that? I'm going to put moles up here. Now I'm going to look over here. Does this have something to do with moles?
No.
200 milliliters? No. What about 2.5 moles per liter?
Yeah.
Certainly 2.5 moles in 1 liter. And then moles cancels out. And I'm left with liters on the bottom, which I don't want. I want grams. I need to get rid of liters. So where should I put liters? Up here. And this says 200 milliliters. If I write 200 right here, is that going to work for me? No. I'm going to need to convert that into liters. So I'm going to need to say that that's 2/10 of a liter. And then liters is gone. And then I'm good to go. We'll calculate that in a second and see if we get the right answer. This one down here, I need to start with liters because my answer is liters. Does this number have anything to do with liters? It says 4 molar. But what's 4 molar actually mean? 4 moles per liter. So watch this. 4 moles per 1 liter. We just flipped it upside down, but we can do that. It's cool. Now I've got liters on top, which is what I want. I do not want moles. I need to get rid of it. So where do I need to put it?
On the bottom.
On the top, in this case, moles. And then we've already used this number right here. So I'm going to cross that one out. We haven't used this one, and we haven't used the molar mass. So which one, this number or the molar mass, has something to do with moles?
The molar mass.
The molar mass. The molar mass says that 1 mole of the stuff contains a certain number of grams. And we're talking about lithium bromide. And lithium bromide, I just looked it up on Google, has a molar mass of 86.85 grams per 1 mole. So now moles is dead. I'm left with liters per gram if I stop here, but I'm not going to stop here. I'm going to keep going because I don't want liters per gram. I just want liters. I need to get rid of grams. So where should I put grams? On the top. And I still need to use this number. Look at that. It's in grams. Everything's cool. 100 grams. That's how much solute there is in this solution. So I'm just going to put that over 1 like that. Grams is dead. And the only thing left is liters. And that's what we want, is liters. Finally, this one right here, we want moles per liter. So I want moles on top. Does this have anything to do with moles?
Yeah, no.
No. Does this have anything to do with moles? No. But this does, right? The molar mass does. So for iron 2 chloride, 1 mole of it weighs 126.75 grams. Do we want moles on top? Yeah, we do, because molarity means moles per liter. So we want moles on top. Do we want grams on the bottom?
No way.
No. So we need to get rid of grams. So I'm going to put grams up here. Does this number have anything to do with grams? No. What about this one?
Yes.
200 grams in the solution. Yeah? So now we got rid of grams. Are we done? Are we trying to figure out how many moles? No, we're trying to figure out how many moles per liter. So we need liters on the bottom. So what I can do, I can either put my volume of my solution in liters down here, or I can put it down here. It doesn't matter in this reciprocal. I'm going to say that we need 0.45 liters of solution. And I need liters on the bottom, so I put it on the bottom. Now the only units that are left are moles, which are on top, and liters, which are on the bottom. So that's what we want right there. So now I'm going to do my calculations. I'm going to do 138.21 times 2.5 times 2/10, and that equals 6.9 grams. Whoa. Oh, it's in scientific notation. Bummer. So 69.1 grams, which is what our answer is. Yeah? Oops. Which is what our answer is. Okay, this one right here, we're going to do 1 divided by 4 divided by 86.85 times 100. This one down here, we're going to do 1 divided by 126.75 times 200 divided by 0.45. What do you guys think about that?
Good.
Mm-hmm.